The first item in the RX1 kit you would have completed will be the tone generator board. There's no reason why you can't test that board before you assemble the rest of the kit. So what I've done here temporarily, I've taken the battery holder and the snap and I've connected it up to the noise generator board. I've used a little pigtail here from one of the resistors as a test terminal. First thing we should do is just check that we've got the 9 volts here. It's 8.91, that's okay, that's from the battery. We've got a Schottky diode in series with the positive voltage from the battery. That's just to protect the circuit board in case I accidentally connected the battery snap the wrong way around. If you do that, the transistors could be destroyed. Next thing is to check the Zener diode voltage, 6.67, that's okay. And the collector voltages on each of the transistors. They should be roughly half supply, 4.6, 4.6 and 5.4. It's important when doing this test that the tone trim pot here is turned off, in other words fully clockwise. If you have too much tone, it will affect the readings on one of the transistors. The tone generator is not a square wave, it's a spiky waveform, and this particular transistor, for example, spends more of its time switched off than on when the tone is present. I'll just turn the tone up just to show you that, and I'll remeasure that voltage and you'll see it's now 6.6. So it's gone up and a bit more, halfway, making a bigger square wave, and it's now 8.36. Now a receiver is handy while you're doing this. I have got a shortwave receiver here. I'll just turn it on. So plenty of noise there. And what I will do first, I'll adjust the noise trim pot, which is really adjusting, I'll just turn that down, really adjusting the Zener diode current. It's a resistor in series with the 1K on the board. When the trim pot is fully one way, we have just 1K feeding the Zener diode. That's around about 3 milliamps. There's 3 volts drop across there. And when we have it the other way, we have 6K, which is half a milliamp. I find that about halfway gives maximum noise. One way. A bit hard to pick it there, but around about there. Now I'll wind the tone up. Hear the tone come up. And there's a bit of interaction. As you can hear there. So that's a good spot. So we know this board is now working. The next step, I'll just show you some waveforms on the oscilloscope. We've connected the noise generator board up to the oscilloscope, and that's the output of the noise generator without the tone switched on. The oscilloscope is sitting at 2 volts per division. So we've got roughly 2, 4, 6, 8.5 volts peak to peak of noise coming out of the noise generator. I'll now adjust the noise bias trim pot, and you can see some small changes in the noise. Not so much the amplitude, it's not so evident, but you'll see some thickening of the trace above and below. I like to set it where the thickening is about even, which is around about there, indicating that the noise is clipping equally on both the positive and negative rails of the amplifier. Okay, it's a bit, the crow doesn't like the noise, obviously, as a trigger signal. Difficult to. Now I'll wind the tone up slowly at first, and you can see the spiky waveform coming through. It's a differentiated pulse out of the tone oscillator. That's a little bit of noise, a little bit of tone, sorry. And see if we can get the triggering on that a little bit better. And as I wind the tone level up, you'll see it almost cutting the noise off completely. If we turn our receiver on, might be able to hear that. Bring the antenna close to the noise bridge circuit board. There it is. Hear that? Okay, no tone, a little bit of tone. It's not too bad there. It's adjusting the bias trim point, and the Zener also has an effect. The waveform out of the tone oscillator is shown there, and its frequency is roughly 500 cycles. And we can show that on a frequency counter, or you can use the time base. That's half a millisecond per division. That's 1 millisecond per division. So as you can see, one cycle occupies 2 divisions, which is 500 cycles. And if we connect the frequency counter up and turn the camera over to that area, 537 cycles. Okay. Well, that completes the testing of the noise generator. Right, during the testing of the noise bridge, I accidentally shorted the base and collector together on one of the MPSH transistors, and found the output on the oscilloscope was quite low, only a few hundred millivolts instead of 10 volts. So I had a look to see what was wrong, and I discovered that there was one transistor destroyed. That's this one here. I'm just going to show you how I checked it. Most people will know how to do this, but with a multimeter, which has got a diode checker on it, just shown down here. Just see that in shot, hopefully. Okay. On the good transistor, which is this one, put the positive lead of the meter on the base, and you get 0.793 of a volt shown. And similarly from base to collector, they're usually the same. They vary from 0.55 to 0.7 or 8 of a volt, depending on the exact type of transistor. When you reverse the leads from base to emitter, it's open circuit, and also open circuit to the collector. So positive on the base to emitter, it's a diode of 0.79 volt drop, and also from base to collector it's a diode. Collector emitter should show open circuit either way around. Okay, so that's a good transistor. Now the one that was blown up, if I put positive on the base, I get nothing. I get 0.46 when it makes contact. That's it. Got a bit of muck on the needle there. And so base to emitter shows 0.46 of a volt, and base to collector 0.683. They're not the same, and that's not a good sign. Now negative on the base to emitter, same reading, and negative on the base to collector 1.3. That's not right either. Emitter collector 0.993, and the other way around 1.5. So this transistor that was destroyed is basically a blob of silicon, behaving a little bit like a couple of diodes fused together. So if you find that the noise output isn't as high as you expected, and you will get some noise out of the bridge, it just won't be very loud. Check that your transistors haven't been destroyed. This was caused by me when I put the probe on the collector, but accidentally went between the collector and the base, and that put the full voltage on the base, which drove the transistor fully on, and it burnt out. So just a little tip there.